Hello everyone, welcome to another tutorial. In this tutorial, you will learn how to efficiently process rasters that looks like this. You can see that over here we have quite a number of rasters and how to process these rasters to extract information for any number of stations that you might have. For example, you can see over here we have around 8 stations. So if you want to extract the information from each and every raster which I showed you, and to finally save those time series data into CSV files like this, extracted from each and every raster, you can stick with this tutorial because I'm going to explain the exact process that you would need to follow in order to do this in a much efficient way using Python, GeoPandas, and a few other required geoprocessing libraries. So let's get started. So if you go into this climateserve.servierglobal.net, this website, you can easily download a set of chirps rainfall data either by specifying a custom polygon to cover the region of interest, cover the area of your interest, or you can directly load a GeoJSON file to specify the area, and then you can directly do a bulk download of the raw chirps data. Now in the previous tutorial which I did, I already did this, so I'm not going to do it again. I'll just show you how it looks once I have finished downloading the different rainfall rasters. You can see over here the first raster is of 2010 1st of January, and it extends all the way up to the 2015 31st of December. So for each day we have a rainfall raster, and if you visualize this in a GIS software like QGIS, you can see that actually my area of interest falls somewhere in the Southeast Asian region. And this is one of the rasters that I have downloaded. You can see my area of interest over here. And how to interpret this raster, you can see actually a range of values over here, and you can see actually the gradient increases from 0, which corresponds to red, and all the way up to dark blue. Now if I zoom in and if I go over here, the selection tool, and if I select one of the cells and if I check the value, you see that the value over here is 0. Similarly, if I check one of these dark blue values, you can see that the value is 34. And if I check another value, maybe this yellowish cell, you can see that the value is 21.6. So these values basically correspond to daily rainfall values recorded for this particular day. And that day is actually given by the heading of this, by the title of this raster actually, 19th of January. And similarly, we have actually quite a few number of rasters for each corresponding day. For each day from 2010 all the way up to 2015. And if you were to actually extract the data, these daily rainfall data, and if you were to convert that into a time series, you can do that using the method I employed in the previous video, where you write an algorithm using the raster.io Python library, and for each iteration you actually read each and every raster. You extract the raster value from the raster, which is actually the rainfall value, and you sort of put it into a pandas data frame, and you save it as a CSV file or something like that, and you can have a continuous time series. But let's say for a case that you have multiple number of stations. Now you see over here I have actually around 8 stations, and if you were to follow that algorithm where you read the rasters during each iteration for each station, that's going to take a lot of time. So in this tutorial I'm going to show you a much faster way of doing it for multiple number of stations. In this case, what we do is, what's different from the previous method is that in this case we will actually still read each and every raster just one time, but after that everything that we read from each of these rasters, we will save it as arrays. For example, you can actually weave this raster as an array with certain dimensions, and that those dimensions will be equal to actually the number of cells in the vertical and the horizontal direction. And you can actually extract the data in terms of the raster values into a Numpy array, and you can show and you can save those Numpy arrays corresponding to each and every day into a pandas data frame again. There's a technique of doing that, and later we can make another iteration which iterates through the x and y coordinates of each and every station, And then instead of extracting the data again directly from the raw raster, we can actually start extracting the data directly from the place where we stored those information into the memory, into a variable. And that technique is much faster than the previous technique, so that you can do your extraction processes fully automatically just in a matter of seconds, or maybe in a matter of minutes. So let's jump right ahead and see how to do this. Now, if you've been following my tutorials for quite some time, you know that the code editor which I would like to use is Spider. So once you have installed Spider, you can navigate from here to the place where you'd actually like to work. And once you're in the File Explorer, you can simply right click over here and start a new module to start a new project. I'm going to name this as started. We need to have a couple of libraries imported, but so instead of importing all the libraries at the beginning, I will actually import the libraries one by one when we need it. So as viewers, it'll be much clear for you actually what is the purpose of importing each of the library when I do it at the place where I really need to do it. So first I'm actually going to read in this shapefile. If I open the QGIS file again, you can see actually we have the stations in terms of a shapefile. So I'm going to actually read that shapefile in, which is located inside the shapefile folder. And I can read that in using GeoPandas. So first I'm going to import GeoPandas as GPD. Alright, then you can run the command and see if you get any errors or not. As you can see, we ran the code without any issue. That means we imported the library without any problem. And now we can use the GeoPandas module to simply read in this shapefile using the read file option. So I'm going to create a new variable called stations, read file, and over here I'm going to specify the full file path. Alright, now we can run this command and see how it looks. If you'd like to see the stations shapefile, how it looks, you can actually just simply plot it by typing station.plot. Alright, now you can see that the stations appear already. Now as the next step, if I also actually open this geodata frame over here, you can see that now the shapefile consists of two columns. The first column is the name of the station. Basically it's station 1 and 2, and the second column is the geometry column, which consists of the x and y coordinate information. So I'm actually going to create two more columns which corresponds to the latitude and the longitude, and I'm going to transfer the information of the latitude and the longitude from this geometry column into those respective columns. You can actually create a new column by just saying that station, and here you specify the name that you would like to have for your new column. So I have specified it to be station longitude, and that's going to be equal to station, and then we select the corresponding column. In this case, we select the geometry column. And from the geometry columns, the longitude is going to be the x value. Right. Similarly, we can write the line of code for the latitude as well. And the latitude value is actually going to be the y value. So now let's run this one and see what happens. Alright, now you can see that we managed to extract the longitude and the latitude value quite successfully into two new columns. I'll just put a comment over here so that it'll be clear later on if you decide to follow along the tutorial. You can actually download all the tutorial files also. You can check the link to download the files in the description below. Alright, so the next thing that I'm going to do is I will iterate through all the rasters, and then I will save the data as individual arrays into a matrix. when I say that I'm going to iterate through all the rasters, what I mean is actually I'm going to sort of run through each and every raster over here, which corresponds to each and every single day, starting from 2010 all the way up to 2015 over here. And I'm going to extract those values in terms of a array and save it. So let's see how we can do that. So the first step is actually to write the corresponding for loop. But now over here, since I need to actually iterate through each and every file over here, I need to identify the name of the file using the OS library, which means when I iterate through the elements of which consist inside this chirps rainfall rasters folder, I need the OS library to identify over which file I'm iterating through. So in order to do that, you can actually simply import the OS library too. So we will write the for loop now. os.listdir, and over here you can specify the location of the directory where you save your raster. Print. Well, let's run and see what happens. Alright, now you can see that it iterated through all of these rasters and it actually sort of it printed out the name of the file. Now inside this folder, in my case actually I don't have anything other than the TIFF files. But in case if someone were to actually keep some other different types of files as well, so I actually want to do some kind of a small where I check the last 4 characters of each and every file name inside over here. And if those 4 characters actually belongs to something other than .tif, then I will just skip over that file. I will only consider the file names which ends with .tif. So I can do that simply by using an if statement. So that will be something like this: if file, and by specifying this -4 colon means we only specify the last 4 characters of the file names, is equal to .tif. Now that means we have actually done all the cleansing of sort of ignoring the files which are not TIFF files, and then we actually have set the program to iterate through all of the TIFF files inside this folder. Now we can start actually asking the program to read in the files. Now, if you were to actually read in rasters, you're going to need another library called raster.io. So I'm going to import that library as well. Keep in mind that installing this GeoPandas, this raster.io library has to be done separately, and I have already made tutorials for each and every library which you need to install separately in my video series. So you can, if you haven't installed any of these libraries before, you can actually just refer back to my video series and try to find the tutorial file which I'm showing you how to actually quite quickly install these libraries. Or actually I can put the link down in the description below as well. Now I'm going to create a new variable called dataset, and I'm going to save these files, save the information from each of these rasters into a file called dataset. So my variable's name is actually going to be dataset, and that's going to be equal to raster.io dot open. Here we are going to open each and every raster, and to do that you again have to specify the full path to the place where you keep the rasters, plus double slash plus the name of the file. In this case, the name of the file will be recorded to a variable called files. So I'm going to specify it over here. And later we can actually extract and save this read information into an array. So I'm going to create another variable called data array, and that's going to be equal to dataset dot read one. All right, now let's run and see what happens. Now if you see over here that it's actually showing you that it's busy, which means it's actually running through each and every raster over here. So that's why it's showing that it's taking some time, because it's actually running through each and every raster and sort of saving the information into this variable called data array. So right now it's not going to do anything, because for each iteration it's just actually going to pass over the files. So right now the information that's getting saved, I mean, with this particular snippet of code, the information that gets saved into this data array variable is just going to be the information which corresponds to probably the last file that it reads. If you open, it's actually reading the files in its own order. So as you can see, the last file it read was actually 2015 February 9th. And you can actually open the data array, and you can see that now what you see over here is basically what you saw before in terms of a raster as well, but corresponding to this particular date, which is the 2015-99, and these values, what you see is actually the values that you see, that you will see if you were to actually open the raster in a GIS file, and these values correspond to the rainfall that it received on that particular day. I think the concept is clear for you guys. And these regions with -9999 corresponds to the areas where data has not been retrieved. All right. And something important that you would need to notice over here is actually the size of this data array. You can see that it's actually a size of 60 by 60. So that means in the vertical direction you have 60 grids, and in the horizontal direction you have 60 grids as well. All right, so the next thing that I would do is actually I would just take this data array that you see over here and then throw that into a Scipy coordinate matrix. It's commonly known as the COO matrix. It's actually given by a module which comes from the Scipy library, a module called sparse. So I'm going to import that module as well now. So you can import scipy.sparse as sparse, and then I'm going to create a new variable called data array sparse. That's going to be equal to sparse.coo matrix, and what I'm going to transfer into a coordinate matrix is my data array over here. So that's data array, and then I have to specify the size of that. All right, now we can run this one, and as you can see that it's again iterating through each and every file over here, so it's going to take a bit of time. Right now you can see that it's done, and if I come over here and then if I just try to see what this data array path looks like, the number of elements which are stored in the coordinate format, and if I just check the type of this variable, you can see that it belongs to the type of sparse coordinate matrix. So I will create a new variable called date. I need to keep track of the date that actually, whenever the iteration happens, I would like to know which date it's actually passing over. So I need to keep track of this. So I'm just going to create a new variable called date, and that's going to be file. All right, when you actually specify this to be colon and -4, it's actually taking, if I go over here, it's taking everything that's behind the last 4 characters. So that's actually going to be the elements of our date. For example, in this case, it's going to take 2010-1-18 as the date value over here. All right, the next thing that I'm going to do is actually I'm going to create an empty matrix. This matrix will be in the form of a pandas data frame, and each and every sparse arrays that we obtain from here through each iteration, I'm actually just going to throw it into this matrix, this pandas data frame. And that's the one that we are going to actually access later whenever we try to extract information corresponding to each coordinate. So we can do that simply by creating an empty matrix over here. So I can actually do that empty matrix creation over here. I'm going to name it as matrix. It's going to be td.data frame. And the matrix value, I'm just going to not pass any arguments. And in the same time, you see that this PD is not recognized over here because normally we import pandas as PD, and we have to import pandas library in the meantime as well. All right, now we'll run the code and see what happens. As you can see that it's iterating all through each and every raster again. And I just want to show you how this matrix pandas data frame looks. As you can see over here, it's actually a completely empty matrix, but it's a pandas data frame. That's what's most important over here, because later we are going to throw in each and every these sparse arrays into this matrix, but with the heading of each and every date that it actually runs over. That's the reason why I'm extracting the date over here in the form of a string, because I'm going to create one column for each date, and I'm going to sort of throw in this sparse matrix under that particular date. So we can do that by simply passing an argument like this. So as you know that in order to create a new column in a pandas data frame, you can just specify something like matrix, the name of the data frame, and then you specify the name of the column over here. But over here, you can see the name of the column gets recorded into a variable called data. So that's why I'm going to specify over here as data. So in each iteration, my name of the column is going to be different. I think you get the idea over here. And that's going to be equal to data array sparse to array dot to. Let's run this once again and see what happens. Or maybe we can actually put another argument, something like print, so for us to see actually which file it's processing at that current moment. Processing is done for the raster. Right, this will show you over which raster it's actually running at that particular time. All right, looks fine to me. Now we can run and see what happens. F5. Okay, we get a small error. Let's try to figure out what happened. Okay, here it should be plus sign. All right, F5. Processing at each iteration. Right now it's done. I would say that this was probably the most complex part of this whole tutorial. The rest is going to be quite easy to understand. And now if I open this matrix, now you can see how it looks. Actually, it's lagging a little bit because of the amount of data that this thing consists, but I think you get the idea. You can see that now each column has its own raster values sort of saved into this. And if I scroll this one, actually it's going to go all the way up until 2015, 31st of December. All right, now the next thing that I would do is I get the corresponding row and column for the related XY coordinates. So we can do that by simply running a for loop again for index row in station iter rows. Station name is actually going to be the row. Now if I open the geodata frame corresponding to these stations, you can see that during each iteration, if you want to extract the name of the station, you actually have to give the name of the column. In this case, actually the name of the column is also name. So I'm just going to pass that argument over here. And in the meantime, I need to make sure that this final output of this part is actually a string. So in any case, just to be on the safe side, I'm just going to convert that. All right, so similarly, I'm also going to create two more variables for longitude and latitude. So in case of longitude, similarly, I'm going to extract it from the row, but now the column name is lon, and this data type it need to be float. And now based on the index, we can actually extract what is the value of the row and the column based on this given x and y. So we can create another variable called row and column, and that's going to be equal to dataset dot index, and we specify the index to be the longitude and the latitude. So basically it's going to be x and y. In this time I'm actually going to print something like processing. I also want to know actually what is the station name over here. Run the code and see what happens. Alright, now you can see that the data extraction was actually very fast, extremely fast. Over here you can see that it passed over all the 8 stations. What I'm going to do is I'm going to actually pick the rainfall value from each stored raster array and record it into the previously created table. So let's actually put a comment over here and specify what we are going to do. Well, in this case it's supposed to be alright. So similarly over here, previously created table. Actually, I think we skipped over the part where we need to create a table. So I'm also actually going to create a table, an empty table, something like this. Maybe I will do it over here. Right, this is going to be an empty pandas data frame. I'm going to call it as table. That's going to be equal to pd.data_frame, and the index, I'm going to specify the index to be a numpy array. So if you need to use the numpy arrays, actually you need to import the numpy library. So I'm going to import it as np, and I'll tell you in a minute why we are going to actually create this table. And I'm going to create something that looks like np dot arrange 0, 1. So later, the values that we extract from this matrix, this variable which actually stores all the information of all the rasters, we are going to sort of do a bit of a transformation and then save those information into this empty table. So let's see how we can do that. So I'm going to actually run another for loop. Alright, so the meaning of this first line is that this is the name of the variable that I'm assigning. So now I'm going to iterate through all the columns of the matrix, and it's better to put the columns of the matrix actually into a list directly over here. Now if I put matrix.columns and to list, actually what it does is it's opening this matrix data frame, it's picking up the columns, all the headings of the columns, and then putting that into a list. So what we are iterating over here is actually the list of the dates, and that's why I have specified the variable to be the name of the records date, basically the specification of the date. Alright, now I'm going to create a variable called a, and that's going to be equal to matrix record date. Alright, now you can assume that when we are iterating through this loop, if I specify the metrics and then within square brackets the records date, from here you can see that actually it's iterating through each and every date. Basically it's iterating through these items, and in each iteration what it's going to save into this a variable is actually the metrics that corresponds to that particular date. So in the second iteration it's actually jumping to the second date, and in the third iteration it's jumping to the next date, and basically it's saving that particular array into this a variable. And now we're going to pick the rainfall value, and the rainfall value is actually going to be a dot location of the row. We need the row to be an integer value, and then the column. Alright, so without going into the further steps, maybe we will run this command and see what happens, what we can see. Now you can see that when we run this, it's actually running through all of these steps. That's why we see it's sort of recording the data again from the rasters. But since this is a tutorial, I think it's fine. If not, you can basically isolate the parts that you don't need to run again and again. But since you're doing this for the learning purpose, I think it's still fine to do this. So if I just open this variable called rainfall value. Now if I open this a variable, maybe let's see how that looks. You can see that this 2015-99 is actually the last date that the iteration picked up, and these are the corresponding information actually pertaining to that last date. So if I expand this a bit, yeah, it looks a bit messy, but what you see over here is actually, so these are the raster values that you see, but this is the index. What you need to understand is actually you have the rows over here and you can see the columns over here. This is the zeroth column, this is the first column, this is the second column, this is the third column. So you can see actually the formatting is not very clear as we would like it to be, but you basically get the idea. So what we do over here is if we open this ref value, in this case let's find out what was the row and the column. So you can see that the row was 39 and the column was 4. So, and as you might guess, this row and column is actually corresponding to the final station that it processed. So for example, for the station number 8, the row and the column was 39 and 4, and the rainfall values corresponding to that 39 and 4 was 25.96. So that's basically the way to interpret this result. I think it can be a bit confusing, but if you spend a little time to actually understand the code line by line with the explanation that I'm giving, I think just in no time you'll be able to understand. All right, next what we do is actually we are going to create a new column in this empty table that we created. You see over here we actually created an empty pandas data frame, and right now there's nothing in it. So I'm actually going to create a new column table. And each time during each iteration, I'm asking to create a new column where the column heading happens to be the records date. Since I want to show you what happens over here, I'll run this code again, and probably this time I'll just fast forward it. Alright, now let's open this table data frame and see how it looks. Okay, now you can see that for the last iteration that it did, that's basically for station number 8, it managed to extract the rainfall values and then sort of throw it into this table, because over here we specified column to be the records date. So each time it iterated, you can see that it actually created a new column, and since it picked the corresponding rainfall value, it actually recorded that corresponding rainfall value inside the new column that it generated. So as you can now see that we have almost come to the final part of the tutorial. Now I think it would be actually good to sort of get this matrix transposed so that we can have this as a vertical column. So that transposing is actually not that hard to do. You can do it simply with one command. Maybe I'll create a new variable called transpose matrix that's equal to the table, but now that's specified by this .t. And I would also actually like to do some renaming for the columns. Maybe we can do something like this. .rename. If I open this one, you can see that one gets transposed. This index 0 is going to be actually the heading over here, means the column name over here. So I'm just going to change that 0 and replace it by a string rainfall, because these values are in millimeters, so I'll specify it like that. So finally, what I would like to do is actually to save the created, and I would like to save the files actually in terms of the name of the station, so that finally our final product will have 8 time series files, maybe 8 CSV files, which corresponds to the extracted time series of those 8 stations. So we can do that simply. Now we get out from this loop because we need to create that that time series for each and every station. So we can create something like transpose, and now we specify where you would like to save this one. Maybe I'll create a new folder. I think that would be easier. Maybe over here I'll create a new folder called time series data double backslash, and over here specify the station name. Alright, so we can run this whole script and see now what happens. Maybe I will open this one. So while it's running, probably you might see that if we don't get any errors, it'll actually create the anticipated files as well. Now you can see that it's actually reading all the information from the rasters again, trying to save it into the data frame that we created. And now you see that it's actually iterating through each and every stations. So you can see actually once the station 1 is done, it got created over here, station 2 as well, station 3 as well, station 4, station 5, station 6, station 7, and finally station 8, and the script is done. So if I open the station 1, well, this is how it's supposed to look. So you have the date column over here, and you have the rainfall values extracted in the form of a time series. And again, if you need to actually do a simple sorting, you can even sort it directly from here. Oldest to newest. Alright, now you can see that the last date is probably 31st of December 2015. And now I can actually simply do a plotting to visualize. These kind of steps actually even you can do it in Python itself, but since we saved the file to be a CSV file, just showing you what are the capabilities now we have with the final product. Alright, now you can see, well, you can clearly see actually the rainfall, the seasonal rainfall fluctuations as well. And the same thing you can actually do with the other stations as well. For example, if I open for station 8, you can see that over here we have the data for station 8. So similarly, any number of stations that you would like, actually you can extract the data from these rasters. And just keep in mind that you can do this on not only for rainfall data, but any other raster types that you might have. You might have to amend the code, maybe not majorly, but then You might have to do some slight modifications, but if you understand the script, I think doing those modifications might not be that hard. But now this actually gives us ability to extract the information in terms of extract the information to a time series for any number of stations in a fully automatic way. So that concludes the tutorial for today. I hope you learned something. If you did, you can comment it down below just to express that which parts that you actually learned as new information. Or if you can actually also extend your support by just putting a comment or hitting the like button. And make sure to subscribe to our channel to actually to be informed about us publishing these kind of very cool tutorials, geoprocessing tutorials using GeoPandas and Python and other associated libraries. So that concludes the tutorial for today. Thanks a lot for watching again, and I'll see you in the next one.